Okay, last video for the week is how you're going to do your lab this week. All right, I uploaded along with the problems, level 2 and level 3 problems we've been working on. I uploaded a short lab outline on the Power Lab. It calls Power Lab Activities, so you're going to use it as a lab. It's going to be a lab. It doesn't take that long to do it. You can do it at home. Yes, you can. You're going to do it at home. Here's what you're going to do. You're going to calculate your power that you can generate. Now, we did earlier some problems, one level 3 problem, that was a power problem. And that was about power generated by an engine of a car moving horizontally. Power can also be generated moving vertically. So for example, if you were going to run up some stairs, that's what we're going to do. Here's a set of stairs, here's you, okay, that is drawn to scale. And you're going to go up the stairs. If you're moving up, you're going against gravity. You're going against gravity. So we can actually calculate how much power you can generate by moving upstairs because you have to do work to go against gravity to get up the stairs. So you're going to determine how much work and how fast you do this, how much power you generate by moving upstairs. So when we get the height from here to there, you're gonna have to do some work. The work that you have to do is to move yourself against gravity. So what you're doing is you're moving your weight. You're moving your weight against gravity. So the work that you do to move yourself your weight is the work that you do against gravity because gravity is pulling on you, and that's what weight is. Gravity's force of pull on your mass. All right, so how are we going to generate, how are we going to figure out how much power that I do? Well, let's take a look at our power equation. Power is work over time. And remember in an earlier problem that I was to show you different videos, the different kinds of power equations there are. The next one that we can break this down into is force times distance over time. Okay, this is the key to calculating your power. Well, all right, let's see, what do you mean? Well, all right, you're running upstairs. Well, I hope you're running. You don't have to. I mean, you can wimp out and walk or even crawl upstairs if you want. Okay, fine, be that way. But let's see how much power you can generate. I hope you would try to move up the stairs as fast as you can. And then power is going to be equal to the force that you have to generate, which is the force of weight. You're overcoming your own weight to move it. So you need to know what weight you're moving, what distance you're moving that weight, and how long it takes you to do this. So you need to know what your weight is. Now, we all probably have an idea of what our weight is. You know, when and maybe you're going to, maybe you get out of the shower, you weigh yourself in the morning, but typically you don't have any clothes on when you're in the shower. If you did, that'd be weird. But you would want to know how much you weigh with what you're moving up the stairs with. If you know what you weigh with no clothes, typically people wear about, this time of the year, about 4 pounds worth of clothing. So add 4 pounds to whatever you weigh naked. If you know what you weigh, or you can just go and weigh yourself before you do this, go weigh yourself before you do this. So get your weight, but we can't put your weight in pounds in here. Okay, that doesn't work. Remember, this is physics, this is international system stuff, so pounds doesn't work. So what I'm gonna have to do is convert your pounds to newtons. You need your weight in newtons. And here's how it works. 1 pound equals 4.45 newtons. So if you know what your weight is, then let's say that you weighed 100 pounds, then that would be equal to 445 newtons. So you are going to take your weight and multiply by 4.45. Just take your weight in pounds. If I weigh 190 something pounds, then I'm going to multiply that by 4.45 and I'm going to get my weight. So how much do I weigh? I weigh like 900. Whoa, dude, you need to go on that grapefruit diet. 900 newtons. Okay, so you're going to need to know your weight in newtons. So that's your weight in newtons. Newtons. Okay. The other thing that we need to know, once we've got our weight in newtons put in here, is we need to know the distance that we're moving. Now, this is not the motion forward. We don't care about that. We're trying to figure out how much power you generate going up. So we need to know how high the stairs are. That's going to vary what set of stairs you choose. I would hope you would choose a set of stairs. There's at least 10 steps. Okay, we got to have some, because otherwise your timing is going to be off. You have some time that'll be good. So 10 steps. Typical household. One story to another is usually around 13 steps, sometimes 14. But you're going to have to measure each step. So you need to measure the height of each stair. And each stair is going to be the same. Okay, that would be really weird if they weren't. That's called being to code. So every step is the same. So measure the height of one step. I hope that you have a ruler or a meter stick or something in the house, or home or apartment or wherever you live, cave, whatever, that you have some kind of thing to measure. And you want to make sure that this is in meters, so measure in centimeters. So measure how high the steps are in centimeters. If you don't have centimeters, you only have inches, then you're going to have to do a conversion, and that's up to you. I'm not going to show you how to do that. You do it yourself. Convert inches to centimeters. Get it in centimeters. So shift your decimal place over, boom, boom, 2 places to the left to get into meters, and boom, you've got your height in meters. Typically, it's going to be around between 2 and 3 meters, depending on how many steps there are. Okay, so that's going to vary person to person. This is going to vary person to person. This is going to vary person to person. You're going to time yourself. Yes, take out the old thingy, what do you call those? Smartphone. They have a stopwatch app on them. Of course, you could stopwatch yourself. Time yourself going up the stairs. So some parameters. You can't take a running start and go up the steps. No, that's cheating. Start from the bottom, both feet on the ground, and then set, go. Time. Both feet on the top, stop. Don't pull yourself up with a handrail. Of course, if you're starting to fall, whoa, 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 grab the handrail. That's okay. We don't want you to get hurt. And if you're a total klutz, then maybe you should walk up the stairs. Of course, we're going to laugh at the power you generate. We're throwing the gauntlet down here. Gauntlet. Threw it down. Threw it down. Okay? We want to see how much power you can generate. Maximum power means maximum force up these steps in a quickest amount of time. So that's really what it comes down to, is how quick you do this. So how many times do you think you should do it? Well, nobody's really getting any exercise today, so nowadays everybody's inside, so how about 50? That'd be awesome. Okay, maybe not 50, but 3 times, and then get the average of those 3 times. So get your 3 times that it takes you to go upstairs, write that down, write that down, write that down, and then what do you think you're going to do with those 3 times? Get the average. Yes, take the average. And put the average time 3 times, and then take the average and place it here. And then when you multiply height in meters times your weight in newtons divided by the average for 3 times to go up the stairs, you will get how much average power you can generate. All right, this will come out to be in watts. Come out to be in watts. Power will be in watts. But let's figure out how many horsepower you can generate. Let's get into terms of horsepower. All right, 300 horsepower. That's what I'm talking about. Those are some sweet cars. Now, how much horsepower can you generate? So what we do to get horsepower is we take the watts and we divide by 746, because 746 horsepower per watt. So divide by 746, that'll give you how many horsepower that you can generate as you're bursting up those steps. Now, I'm going to throw it out there. You ready for this? Gauntlet time. Ladies, all right, ladies, it is difficult for most females to get above 0.8 horsepower. That is what I call a cutoff. That is hard for most females to be able to generate. Most males, if they're trying, can get this 0.8 horsepower or higher. Okay, so now I know what you're saying. You're saying to yourself, oh, that sounds pretty sexist, don't you think? Sexist. It's not sexist, it's a fact, okay? The fact is most women cannot get 0.8 horsepower. Throw it down, show me, prove me wrong. Prove me wrong. Absolutely, some can. And most men, if they try, can get 0.8 horsepower and greater. All right, see if you can get that magic number. Now, if you can generate 1 horsepower, some guys are like, oh, man, look at me. You can generate a horsepower. Man, I mean, powerful as a horse. Oh, yeah, okay, really? But let's be fair. When James Watt was doing experimentation in England 150-something years ago using draft horses, he was having them do work for a long period of time, an hour, at a time. So if you really want to compare yourself to a horse, we'd have to be running these stairs for an hour. And let's see if you can keep up 1 horsepower. Doubt it. But for that quick burst, maybe you can. Maybe you can. Okay, so once you've got your horsepower calculated, put your calculations, put your data down on your sheet of paper, and just email that to me at my email address at MCC, and that's your lab. It's pretty quick, pretty easy, and if you just do it, you get 100. You just do it, you get 100, okay? Does it get any easier than that? Yeah, you can just put 100 in for us anyways. No, Janie, no. Okay, do it. That's your lab for the week. Have fun.